So I have been working on a pathfinding system for my game for the last month, but unfortunately my tech lead skills had let me down, and I really cannot say that I am a full tech lead dev yet, but if I compare my skills to a tech lead skills, it will be like comparing 1 to 100, and by using common sense I can say that there is a little to no gap between them. So anywho, instead of searching for a pathfinding algorithm, I thought I can reinvent the wheel and create my own pathfinding system. And in my solution, I tried to give priority to performance. So instead of looping through the entire floor array, I thought I can cheat and have a solution that doesn't loop through the entire floor array. But it didn't go as good as I wanted because it needs a lot of if statements, and that's a big performance hit. And at some point when the path is blocked with a lot of disks, my pathfinding solution couldn't handle it, and it goes through a infinite loop or even crash. So my solution was like 600 lines of code, and it is as big and as bloated as the most optimized closed source project by charm. So finally I come back to my rationality and I searched for a pathfinding algorithm, and here is the summary of what I have found. So one solution for a pathfinding problem is the depth first search (DFS) algorithm. This algorithm is looping through the map array and try to find a path through to the destination, but it has a drawback. This algorithm go as deep as the map grid, and that's not efficient, especially with my game, because the places that the employees will go to are close by, because the game will force you to do so. Another algorithm is Dijkstra. Okay, this algorithm keeps track of the total cost from the start to every node that is visited, and this uses it to determine the best order to traverse the graph. And unlike DFS, it can have a step distance bigger than 1, and it works with weighted graphs. And my understanding of weighted graphs is that every path from a node to another node has a cost, which means the distance between a node to another node, or the time that you need to travel from a node to another node. Okay, so that's actually not a practical solution for me, because the distance between each of the nodes in the game is always 1. And there is also a star. It's like Dijkstra, but it has implemented a technique of the best first search algorithm, which make it more efficient, but still it's like Dijkstra, and using a weighted graph is not a solution. So what is the solution? Enter breadth first search. Breadth first search algorithm, or BFS in short term, is another pathfinding algorithm. This one is searching in neighbor nodes and slowly moving away from the original node, and it has a step distance of 1, which is ideal for my situation, and also it is working on unweighted graphs. And if you don't know what unweighted graphs are, basically they have no cost for any of the paths from a node to another node, and the nodes are connected via edges, so the algorithm will search in neighbor nodes that are connected via edges. So let's take a look at BFS. Let's say that we have a 3x2 grid. The node number 0 will be connected to the node number 1 and node number 3, and the node number 1 will be connected to node number 0, 2 and 4, and so on. And if there is a node that is full, meaning you cannot move through it, you shouldn't connect it to its neighbors. So this is a graph that demonstrates that. As you can see, you tell BFS what are the edges of every node, and that way it knows where and where not to search. So every node has a number, and every node is connected to its neighbors. That's shown by the orange yellow lines. So if you are confused about this graph, I also did at first, but the next two graphs are very easy to understand, and I think that even a 6-month-old baby can understand it. So this is the first graph, and this is the second graph. See, very easy. And if you didn't understand what all of this is about, we have baby Johnny here, and he will explain it to you. Baby Johnny, please explain. Yeah, and that's exactly what they mean. Thanks, baby Johnny. Let's move on. No, I'm just kidding. So in the first graph here, we take each node and we connect it to its neighbors. So we have 0, and the arrow points to the nodes that are connected via edges, and it is connected to 1 and 3, and 1 is connected to 0, 2 and 4, and so on. On the other graph, we have all the nodes on the row and on the column, and if a node is connected via edges to another node that cross with it in the grid, we mark it as 1, else we mark it as 0. See, they are very simple. Even a 6-month-old baby can understand it. So this is the BFS code, and this is not that big, only 87 lines of code. So with this new knowledge, I gathered my tools and start coding, and after years and years of implementing BFS and hard work, let me check this out. So last video was 2 weeks ago. Yeah, I don't think they will notice. So BFS work with non-nested arrays, and that means that if you want to know the neighbor edges, you are pretty much screwed. So one solution is to store the vector2 size of your map, both x and y, and you can use some fancy math to deal with your non-nested array. So this is the result. I hope you like it, and goodbye.